do we have to solve it? We need to find the maximum population, and we have this function, but I don't know how to use it.
We have to find the maximum population and also the length of time between successive periods.
We need some help.
Look at the screen, everybody. This problem cannot be solved in any programs. It can be solved by harmonic motions.
And what is that?
Let's see.
What is periodic behavior? Behavior that repeats over and over again. It follows a kind of pattern. When is an object in simple harmonic motions? It happens when the accelerations on one body or object is proportional to its displacement, but acts in opposite directions. Simple harmonic motion is repetitive movement back and forth through the equilibrium positions. If the equations describing the displacement y of an object at time t
Amplitude is a distance from an equilibrium axis to highest or lowest point. And period is a time which is required to complete one cycle. And frequency is a number of cycles per unit of time. By using the simple harmonic motions, we can analyze the behavior of sound waves, electromagnetic waves, oscillations of a pendulum.
Damping harmonic motion. In the presence of friction, however, the motion of the spring eventually dies down. That is, the amplitude of the motion decreases with time. Motion of this time is called damping harmonic motion. Damping harmonic motion is simple harmonic motion for which the amplitude is a of t equal to k e raised to the minus c times t, governed by the function. When the equation is describing the displacement y of an object at time t, the equations are y equal to k e raised to the minus c times t sine omega times t, or y equal to k e raised to the minus c times t cosine omega times t.
In the equation we have different variables from the damped harmonic motion. For example, k in the equation is the original amplitude, e is the same constant as used in logarithmic equations or functions, c is the dampening constant, t is time, we use the trigonometric ratio, omega is the horizontal stretch, and t is time.
Thank you, Mommy. Now we can solve the problem and we can do the homework. We can observe that in this function we can solve all the problem with the help of this graph. Yes, the maximum population we can observe based on the graph 8,000 plus 900 that this is the amplitude, and the answer will be 898,900. Yes, and we can find the length between the maximum population and this point to this point. This is like one period, so we can solve with k that we have here, that is 2. So 2 pi, that is one simple period of cosine. We divide by 2 the k, and we have that the length is pi only. Thank you, Mommy.
We have to add the amplitude plus the equilibrium axis.
Are you okay, my friend?
I don't know.
You just remind me of a patient that I had a long time ago who had a heart disease. But just for in case, just let's measure your blood pressure, okay?
Okay.
Okay.
Am I gonna be okay?
You're just okay. Let me measure your blood pressure.
You have a little problem, but nothing serious.
And what happened to your other patients that had the similar problem?
He died, but before he died, he made up blood pressure diagrams so he can see his heart disease.
Okay.
Okay.
This graph represents the result of your blood pressure test. The highest point of your blood test will be 2 p.m. will be 100 millimeters of mercury, and your lowest point will be 2 a.m., which produce 80 millimeters of mercury.
Okay, I see you used a function of a sine to this. I suppose it's a harmonic motion. I remember I saw this in a math class. First, to the vertical shift, which is a 90. I know that it's the equilibrium axis because it's the vertical shift.
Yes, that is your normal blood pressure.
Okay. Well, in order to get that it starts at 8, a graph of sine, it will be the midpoint between 2 a.m. and 2 p.m. So the graph actually starts at the equilibrium axis, which is the characteristic of sine. To the horizontal stretching, I see you used the period formula. As the period is 24 hours, and we have that it's 2 pi over omega, which whereas omega is the horizontal stretching, clearing omega will actually make us able to get the horizontal stretch, which will be pi over 12. To the amplitude, the distance from the equilibrium axis to the highest or lowest point is 10, as we can see here in the graph, from 90 to 80 or to 100. So, well, the vertical shift is in the equilibrium axis, as I already said.
That's correct.
Oh, then I'm not going to die.
No, you're just normal, don't worry.
We can conclude that harmonic motion is present in daily life, and it has many applications. The theory of its formulas is based on the trigonometric functions in order to model the periodic behavior. We can use these formulas to predict the behavior of waves of sound, for example. Also, it can be useful in medicine for calculate the patient's heartbeat or blood pressure pattern to know his reaction to some treatment or test.